This is today our third webinar at the CFCI. My name's Simon Smith. I'm the chair of the CFCI, and today we're here to listen and see a panel discussion, a presentation on Magdalene College's new library. We were due to have a physical site visit at the end of April, so that was cancelled, and we're now giving you a virtual site visit today. Today we have 5 speakers, but we've also got some panelists as well for the Q&A at the end of the presentation. So we've got Neil McLaughlin, Claire McMahon, Tim Allen Booth from Neil McLaughlin Architects. We've got Julian Redpath from Coxedge Builders. Julian's the site manager on site, and he also was involved in the pre-contract work on the project. We've also got Oliver Diggins from Savills, the project manager. We've got Ben Sellers from Max Fordham, the M&E engineer, and Fernando Perez from Smith & Woolworth, the structural engineers. So we're going to have 5 speakers today. Each of our speakers is going to speak for about 7 or 8 minutes. So if you do your maths, that will allow us around about 15 minutes at the end for Q&A. I'll give our speakers a polite 2-minute warning when we get close to their point, but hopefully we'll manage to keep more or less on time today. So for the people, for our attendees, and we're still rising, but there's about 120 listening in. We won't be able to see you or hear you today, but we will be able to take questions from you. So for those who are new to Zoom, on the bottom of your screen, you should be able to see a Q&A bar or tab. If you start typing in your questions as we go through the presentation, that will enable us to see what questions are coming up, and we'll put those questions to our panelists at the end when we have our discussion. So, design this concept
Sorry, Simon, your voice is breaking up very badly. Can I just suggest that all participants in this mute their, if they're not speaking, if they mute, it might help Simon's voice. Okay,
it could be might be my internet with Mr. Branson. I don't think it's living up to his promises on my internet at the moment. Anyway, so what we'll do is we'll kick off first of all with Neil, and as I say, then we'll have 4 other speakers on the various topics, and they'll talk about the design, but also move a little bit more into some of the construction detailing and images that you'll see. So without any further ado, Neil, could we move to you, please?
Thank you very much. I just wanted to say in preface to this talk that I think from the point of view of our practice and the way I wanted this to be represented today, it has been one of the exemplary collaborative projects that we've worked on in our time, both in terms of the team of consultants that we've worked with and with the contractor Coxedge. It was very enlightened of the college and through Savills management to put together a team of people who knew each other very well. We've worked on the Jesus College project with Coxedge, and we've worked on numerous projects with our engineering colleagues. And so it's been, I have to say, for us, a very enjoyable process, and one in which the construction and the engineering and the logistics and the physics of the building have been an extremely important part of the way in which it's been elaborated. Next slide, please. I want to just move from that first photograph you saw, which is an aerial view of the building, to this very simple model, which has been in our office for a few years. And it's rare that you can make such this is a tiny model, it's about the size of an iPhone. And it's rare that you can make such a simple, small model to encapsulate an idea. But the simple principle here is of a very regular square grid of chimneys, which both support the building and take all of the air out of it. And I like the fact that you have both structure and environment in the same system. The buoyant air is rising up and the load has been carried down to the ground. And between that, you have these very simple roof structures which bring in light from different orientations at different times of the day. And that gives you a very simple tartan grid in the building, which is extremely regular on the inside and highly systematic. And it's interesting working in a city like Cambridge, where one was doing a project in a very contextual setting. If we move on to the next slide, you'll see that we have the context of the college itself and its position by the River Cam between the Master's Garden and the Fellows Garden, and its proximity in particular to Second Court and to the Pepys Library and the Master's Lodge. And so it's, the setting is highly sensitive, but it's been possible for us to put a building which is a very rigorous underlying order into it, and to allow the demands of the building working out from the inside and the demands of the site pushing back in from the outside to come together, and for this order to operate for both of them. So looking at the building, we have the Pepys Library here. I mean, the Pepys Library is an extraordinary piece of architecture with this stone facade on the front, very strange mannerist composition with the loggia at the base and these funny gables at the top that slide past each other. It's very erudite, very mannered, a very knowing kind of composition. But the back of the building is incredibly simple. It's like the kind of complexity of the front disappears entirely when it turns around and looks out towards the river. And then it's a very plain-spirited brick building. And it was really that plain spirit that we wanted to interpret, that sort of ordinariness with the simple pitched gables and the rather beautiful brickwork. And we have these fantastic yew trees on the site. We thought we could make a new court surrounding those yew trees and put a building of around the same size as the Pepys Library beside it. And you can see that that architectural model that we showed you a few moments ago is echoed in the CGI here, where you have the brick chimneys, between them these very simple zinc-clad timber roofs, and then hanging from the spaces between the chimneys, these oak windows that give you views out into courts and lawns over the river. Next slide, please. There's a simple staggering in the plan which has to do with the existing protected trees on the site. The ground floor plan has got a long gallery, which you can see at the bottom of the page, which will be a picture gallery which looks out onto the lawn. You enter the building from that yew court on the left-hand side in the middle into an entrance area. And if you turn left, you're in the library. If you turn right, you're in the gallery. And if you look ahead of you, as you'll see later on, there's an exhibition room for the archive, which is just behind you. If you had turned left into the library, you enter into this triple height space. And it's something that we've always wanted to do, which is a triple height space, which is overlooked by a double height space, which is overlooked by a single height space. And we hope that you can see diagonally right the way through them when you get to the building. So the triple height space is bringing light down from a roof lantern 3 floors above. And you can see that order there, the constructional order coming out of the organizational order with the brick piers rising up, and between them precast beams, and resting on those beams glulam columns with CLT. So it's a highly organized system which is just repeated throughout the building. And so we rise up a staircase on the left-hand side of that image, leaving behind the librarian's desk. And it's really on the first floor plan that you can see the fundamental order of the building. I'm just going to move to my, and of course I can't use the annotate option here. In the middle of the bays at the top of that plan, you can see the triple height space. And it's overlooked by the double height space, which is at the very center of that plan with the long tables. And that's surrounded by a number of rooms, which are breakout rooms. And the double height space is a double bay. So we have this nice thing where the triple height space is 1 bay, the double height space is a double bay, and the single height space is the whole length of the building, as we'll see in a moment. So from that double height space, you can both look down beneath you and up into the spaces above. Claire, can you give me an image of the double height space? So this is the sort of central reading room of the library. On your left-hand side of that image, if you leant over that balustrade, you'd be looking down to the space you've just come from. It's in the nature of the plan that it gives us what we call a tartan grid, which is wide spaces and narrow spaces. So all the circulation and bookcases are in the narrow spaces, and all the reading rooms and places to sit and read are in the wider spaces. But you always have this motif of the roof lanterns overhead with the light coming through from different directions. And in the back of this, you can see a bridge that crosses the space between 4 of the chimneys. So as we move up through that space, we'll go up a staircase to our right-hand side between the bookcases, and we arrive up to the top of the building. You flipped away from that slide, Claire. There's a photograph of the roof structure as you arrive up to it, still on site under scaffold, but you get a sense of those CLT structures. which are sitting on top of the piers. And on the next slide then, if we can move back down to the top floor plan, you can see that we now have a room which is a single height, but 3 bays long. And so the sense of it getting higher and wider as you go up. The key thing about this single height space is you can stand in it and look diagonally all the way back through the double height and triple height spaces, but you can also look out over the lawn and get a view out over the river. That's bookended at each end by separate rooms. And so you have a cluster of rooms around different spaces, which gives you the essence of the building. Next slide, please. Then this is a view of that top floor space. You can see there's a window on the right-hand side, which will give you a view out over the lawn, and then down to the river. And then you see the repetition of those lantern structures stepping away in that 3-bay long room. I'd like to just show you some details now as we move through the building. I think we're going to see another plan, which is the roof plan. You can see just how systematic the building is here when you get to the roof. Each of those square bays is a roof lantern, and between them we have a cluster of chimneys. So it's a very organized and simple building at its deepest level. And that gives us a variety of spaces inside it. And I'm just going to finish my bit of the talk by taking on a tour of some of the spaces that we get out of this very simple form of organization. So here we are on the first floor in a smaller room, which is looking into the big reading room behind us and looking out over the river in front of us, with a long desk flanked by bookcases and the CLT structure over our heads. And the next one, on the top floor, we get a much higher lantern light, but the same view out over the river in a smaller room, which is completely lined in bookcases. And the next one, this is a tiny little reading niche tucked in between bookcases. That's one of the chimneys in front of you. You can see left and right the big windows looking out over the river. And if you're sitting in that little niche there are wooden shutters on each side of you that you can open for ventilation and a glimpse of the river. Next slide, please. And then this is downstairs where we have the archive. This is the archive room at the center of it. The contained archive is just behind us, and this is a display space. And the last slide, please, from my part of the presentation, is the long picture gallery, which looks down over the, so you can open those doorways out over the lawn, this is a long gallery for an exhibition of pictures. So I'm going to pass on now to Claire to talk about the next stage.
Claire, you're muted.
There you go. Can you hear me now?
Yes, we can.
Great. So I'm going to speak about one of the main materials in the building, which is the hand-laid brick and handmade brick. And Coxsage have quite recently placed the last bricks at the top of the ventilation chimneys. And I guess this act marks the end of a very long process that we've been on with many different parties involved in the brickwork package. That involved the college, the planners, the engineers, the contractor, the bricklayers, the suppliers. And the brick is the vertical structure of the building. So the cavity walls that enclose the building are both brick on the internal leaf and the external leaf. And there's a grid of L-shaped piers which repeat throughout the plan in that systematic grid that Neil spoke about, and they rise through all 3 stories of the building to support the chimneys at the top. And I guess to go back a bit to where we made these decisions, and I guess if we were on site today doing the site visit as it was supposed to be, on the way to the site you would have passed some of the existing buildings in the college, and most of those buildings are very old, hundreds of years old brick buildings. These are some of the examples. And you can see that the surface is very soft and textured, and the repair work that's been done over the years creates this really rich tapestry on the surfaces. And this is the Peeps building, which Neil spoke about. This is the elevation onto the Fellows Garden. And this is the build, while the other brick buildings in the college were important as a reference, this was the focus of our studies. This elevation sits alongside the longest elevation of the new library, and both look onto the Fellows Garden. This is a close-up image of that elevation, and as you can see, there's quite a diverse mix of reds, browns, purples, and from a distance that it looks quite brown. And one of the things that we studied a lot was the size of the mortar joints and the impact of that. And we agreed with the team that the most appropriate size of brick for this building would be a brick that's smaller than a standard brick. So the brick that we decided to use would be 5 mils smaller in every direction, and the mortar joints would be 15 millimeters. And you can see in this as well that the joints are flush and with a lot of visible aggregate. So that's something that we worked to achieve in the new building also. We looked at lots of different types of brick, and I guess the first brick that we chose actually went out of production, and we started the task again, and we brought all of the bricks to site and we compared them to the Peeps building. And the brick on the left, there is a brick that Coxage had actually used on a previous building that they worked on, and we looked at it closely alongside the Peeps building, and we all agreed that it was the most suitable brick to sit alongside that building. And we then went to the factory in York with Coxage to understand more about the process. And I guess at this point, this was very helpful because we were at the point where we were trying to figure out the exact colours and the exact mix and the mortar mix. And this helped us understand the range of colours that you can get in even one batch, and the sort of tweaks that you can make in each part of that process to achieve the different colours. And I guess the purple brick was one that we were very keen to get into the mix. And these are some of the molds that are used in the factory. And because of the non-standard size of the brick, we had quite a lot of specials. And there was a mold made for every single one of those specials. So that was really interesting to see how that process happens. This then is the 4 bricks, the 4 different colours that we chose. And we then went through a process with Julian and his team they built lots of sample panels on site. And this was to determine the exact ratio that we would go with for the brick, but also to figure out the right mortar mix. And we really saw from that how the colour of the mortar affected the overall colour of the building. And I think Julian will speak a little bit more about this, but we achieved, this was the final panel that we arrived at, and the mortar is a mix of lime and cement and sand, and then it's brushed to make the aggregate more visible.
2 minutes, Claire.
And another aspect then, I guess, was the bond, and we wanted to reflect the load-bearing nature. So it's the main walls are English garden wall, and we express the floor lines with these soldier courses, and then again the L piers extend to the external leaf, so that is expressed by this recessed joint that runs full height. And I guess the list of specials was quite long. I think we had one for every letter of the alphabet, and each of them was named after a letter of the alphabet. And then we developed these drawings that were a bit like jigsaws to explain the more intricate parts. So these are the chimney drawings. And it was very nice then to see on site when the bricks turned up that they all had their name imprinted onto them. So this is some of the specials arriving. And sometimes on site it was a little bit like a brick maze. And Julian will go into a bit more detail about sequencing and organising that. And I guess this was a nice moment in the building when the brick piers started to rise through the first floor slabs, and when the lintels were starting to be built into the brick and the timber being set on which Fernando will go into in more detail. And then this was another nice point where we were able to look back through some of the newly formed window openings, and you can see back to the existing buildings that we had first looked at when we started working on the project. That's all from me. I'll hand over to Fernando now to speak about the timber structure.
Thank you, Claire. So I will try to show you some of the most important elements on the timber structure. As Neil and Claire have described, this building in our view, in our black and white view, it looks like a traditional building with load-bearing masonry and timber floors and roofs. However, it has the modern twist that nothing is what it looks. The masonry elements are internally they are reinforced masonry columns, previously referred as LPRs, and externally we have a properly insulated cavity wall to keep the comfort, as Claire was saying, with internal and external leaf in brick. And the timber, it is not just some timbers and boards and joists. It is all engineered timber from sustainable forest. And now we can see on the next slide, everything was off-site manufactured just to be delivered just in time by a company based in Switzerland, or the Glulam. The company is Neue Holzbau, who you may know, all those who have visited the Storyfield Center in Cambridge, and they also were employed on that building. So the quality of the joints was heavily controlled on the factory conditions. Then if we move on to the next picture, we can see again that joint where the load-bearing masonry, vertically load-bearing masonry, goes through the timber floor, and then the exposed soffit glulam beams supporting the CLT decks are sitting onto the precast concrete exposed lintels, which then rest on the 4 internal LPRs or reinforced masonry columns. On the next slide, we can see we are now in a typical, well, at the end of the first floor. We can see all the exposed timber ceiling. We can see here the primary and secondary glulam beams supporting CLT elements, and how those beams in a very rationalized manner arranged, they sit onto the external and internal load-bearing masonry elements. Next slide, I think we can see here as well. So the function of the CLT above the glulam elements was mainly to tie horizontally all the floors and to distribute the horizontal wind loads from the facade to the internal elements as well. And in the next slide, I think we will see a close-up of that grillage of timber beams onto precast elements. The glulam beams, I have to say, are the highest quality appearance, highest quality in terms of surface class and appearance. It's called selection grade, and it's not very easily available. That is to match the highest quality possible as well, CLT on the background that we see in between the grillage of glulam beams, as all of this will be exposed and has been engineered for 60 minutes fire capacity. On the next slide, before we move on to the roof, we see a typical room view with these high quality structural glulam beams. And we are now looking into the garden with the U3, which will sit in between the 2 libraries, as Neil was explaining before. Now, in the next slide, we will be able to see the typical arrangement on the roof level, which is similar in the central areas to the second floor in terms of these flat roof slabs supported on beams are spreading or distributing the loads from the outside facade to the internal load-bearing masonry columns. And in the next slide, we can see one of these flat roof elements from underneath. The geometry is similar, and the only difference is that at this level is where the masonry columns stop, and the internal chimneys, the internal square chimneys continue above the roof offset from the location of these columns. In the next slide, then we can see a drone view of the site, and here we can really appreciate the benefits of the offsite manufacturing. We have on the top left some panels delivered just in time for the installation, and before they were installed on the roof, the crane moved them to another area on the top right of the site where the operatives could safely assemble each of the 12 repetitive 3D lanterns forming the roof in a safe environment down at ground level. And the roofers were also able to install their insulation. And once that was completed, each of the pods was lifted to the final position and rested on the connectors that we will see on the next slide.
A few minutes, Fernando.
Which will take all the weight and all the loads from the 3D lanterns into the load-bearing masonry elements that we had seen in the previous slides. So next slide, please, Claire. Here we can see an example of how those CLT preformed roof lanterns fell into their shoes, literally, and those brackets also incorporated service routes for service distribution above the exposed soffits in some areas of these CLT timber elements. In the next slide, we can see a typical detail of the internal connections from these lanterns into their shoes, and on the background we can see an internal brick chimney. And on the final slide, we will see the typical view from inside with the glulam beams tying these connectors for the roof, completing and transferring all the thrust of the roof into the flat elements that we have below. I have to talk about. And that's it from structures. I think I will pass on now to Julian from Coxets to tell you a bit more about the sequencing.
Thank you, Fernando. Good afternoon, everyone. The first real problems we come across was underneath the footprint of the site, we had the two main power cables that fed Barnwell and Grantchester, which had to be rerouted to allow the site to be piled. Also running through the site, we had the Granta backbone and the cables which feed all the universities' network systems to be removed and rerouted. The building, no one has actually highlighted, sits on 109 piles of 300 mil diameter, and the deepest going in 21 meters. So that was quite interesting for me, having such deep piles on the build. If you can move on to the next slide, please. This was typically one of the walls we built for Claire to express the bond, because when we built smaller panels, the actual colour of the brick wasn't apparent. Everyone was saying there was not enough the dark brick in the bond, but building a larger panel gave a truer impression of the bond and the blend and the colour. Going into the blend, this is a specific blend for Magdalene. It's got their name on it, and no one else will ever have this blend, and it's bespoke to the college. As we said, it derives 3 bricks, being the Lindum, which is a 50% mix of the bond, 20% Hambleton, 14% Thurkelberry, and 16% of the black, which was added to complement the Pepys building. If you can move on, please, Claire. Brick bonds we used on the site, there was 3 main bonds. We used the half brick bonds, which you see in the piers. We used the English garden wall bond, as mentioned by Claire, on external works. And in the chimneys, we had a Flemish bond. So the bricklayers had a good time with those. All the joints were 15 millimeters, which they took some time to get used to. So prior to any bricks being laid on site, Claire and Fernando met with the team, and we spoke to the hand-picked bricklayers who were interviewed for the project about, the importance of this build being the best it could possibly be. The guys we picked had worked on heritage sites before and actually brought into the project and delivered, we think, a very high standard of brickwork. I did actually take some down at some points, but hey, life goes on. Can you move on, please, Claire? The structural, this is the brick, a very small compound we had, which was full of bricks. I think at one point we had 120,000 bricks on site, of which there was 24 specials, as Claire told you, and there was also a load of the non-visual bricks, which no one has mentioned yet, which were a metric brick. So we were incorporating, as we see in this pier, specials, non-visual bricks, which were 65 millimeters thick, and our modelling brick, which is 60 millimeters thick. So not only was we trying to build a jigsaw, there were bricks of all different shapes and sizes, which then again posed more problems. Can you move on, please, Claire? This is just some of the L piers in progress. As you can see, Fernando stipulated they had to have reinforcing through the middle of them, and they had to be full of mortar. Now, we're using two different types of mortar on site in the white colour. So to avoid confusion, we actually changed the mortar in the piers to grey, so that there was no confusion of the strength of the mortar. The mortar samples were taken throughout the build and were sent away for independent testing, of which Fernando received the results. Move on, please, Claire. All of our stairways and lintels were made off-site by Minster Stone down in Somerset. No site measurement was done with these. These are all drawn, all made off plan. So the biggest headache for us was in the stairwells. When the stairs come, the actual load-bearing brickwork was built off of the landings, and the stair landings landed on visual brickwork. So we had nowhere to hide with this to incorporate Claire's 15mm shadow gaps, the stair risers to fall within the landing spaces, and it was a sequencing of, we had to get up to the next half landing before the stairs could go on. So if it was incorrect, we'd have to take down a lot of work. So a lot of time was spent in the levelling and the gauging of the stairwells. They were quite involved. Thank you, Claire. This just shows the L piers with the fair-face lintels, which, as Fernando said, the glue lambs and the CLT sat on. Even these were complex in the fact that they had to be notched to allow for the reinforcing to travel through them. And then the importance of these was gauging again, having the 15mm shadow gap above these where the glue lambs sat, and also the 15mm joint under. Thank you, Claire. This just shows the L lintels, the L piers and the lintels as they stand. The difficulty here was, while we got this drawing, is the bricklayers were not used to building from grid lines. They were always used to building with tapes and string lines off of measuring off solid parts of bricks. But here, the building is built around a grid, and the grid is the most important part of the setting out for us. And it was just re-educating the bricklayers that the grid line travelled up through the building, because when we got to the roof, if we was off grid, the whole building was off grid. So that was quite educational for them, and they did actually say that it was refreshing to build this way. Thank you, Claire. This is one of the planks going on, the CLT planks. Once again, everything was pre-made off-site. There was no cutting on site, so the brickwork, the CLT, the glue lambs, all had to be millimetre perfect, once again highlighting the 15mm shadow gaps.
Julian, I was just going to jump in and mention the recess in the slab for the
Yes.
services to get from one side of a beam to the next. So there's a lot of detail involved in agreeing
Absolutely.
all of those things.
Absolutely. It wasn't just a straightforward slab. There was the M&E to consider as well. Thank you, Claire.
Julian.
Thank you. This just shows the gallery lower areas, Niall said, just in construction. Thank you, Claire. Once again, looking up at the CLT glue lamb elements and how they interact with the brickwork and construction phasing we had to deal with. Thank you, Claire. These are the hashtag lintels. Now these are some mighty lintels. These weigh 2.1 tonnes each, and on top of them they have a 1.6 tonne covering slab. But these are the foundations of which the chimneys were formed. These are also notched to allow for wiring and services to go through. So these ones, again, a lot of work went into these. Thank you, Claire. Just going back to the hashtags, if you look at from the underside of the hashtag, the glue lamb beams, they all travel through at the same. So the hashtag going off at 4 different directions, the glue lambs have to meet exactly to the hashtag. This is just a scale drawing just to show the size of the roof pod parts. Thank you, Claire. Roof pods under construction. We eliminated working at height to the best of our abilities. So the guys built the pods on the floor. They were insulated and felted, as Fernando said, and most of the works that could be done were done on the floor. Thank you, Claire. This is the roof pod being lifted into place. The roof pods each weigh about 3.2 tonnes. So it was quite a task. The first one we lifted on was quite a hairy moment, but I think after the 12th one, we got quite blasé about it, really. Thank you, Claire. Roof pods, the first 3, 4 have been landed. Chimneys are starting to come through the roof. Just construction in progress, really. Thank you, Claire. So this is the view that no one really get, only us at the moment, because you can see all the way through all the roof pods from one end of the building to the other. So that was a nice view and a nice picture to keep. Thank you, Claire. So this is the triple height view up, well, the double height, should we say, but with the 3 meters from the roof space up to the roof pod, it feels like a triple height, just showing the difficulty of the construction of it and the complexity of getting the scaffold and everything in place for all the trades following through. I think that's about it for me. Thank you. And I'd like to hand over to Ben.
Afternoon, everybody. Just to mention, it was a fantastic project to have been involved in. So at Max Fordham, we're involved in providing MEP advice as well as environmental design and lighting and acoustics as well. So I'm just going to talk about 2 parts of this project, first being the natural ventilation strategy and then the archive space. So if you could just jump onto this strategy sketch. So we wanted the library to be naturally ventilated, just to sort of work with the light and airy feeling and avoid any ductwork and ceilings that obviously would have compromised the architectural expression of the floor slabs. The strategy we ended up employing was to use the chimneys at the top of the building and opening windows on the sides. And the interconnectedness of each of the different levels works with the chimneys, allowing air to be drawn in from the bottom and using the stack effect. Now, the height of the chimneys is quite important to their function. This is to ensure that the neutral point is above the windows on the upper level. Now, the neutral point is the level at which air pressure due to buoyancy changes, so that below that level, fresh air is coming into the building, and above that level, warmer, stale air leaves the building. So this is all to ensure good levels of ventilation in the building, even on a still windless day, without the need for any mechanical systems. If you could just jump to the next slide. So this is showing a photograph of one of the central chimneys partway through construction. And the next one, this is showing the perimeter chimneys, which are half the size on plan. The brick construction here from the roof level upwards, it's going to help with the stack effect during warmest weather, as the brick will heat up in the sun and warm the air within the chimney, causing it to rise and pull air through from the library below. The next one, this is a nice shot of across the roof showing the cowls on the top of the chimneys. Next, I'm just going to jump on, this is the archive down in the ground floor. Now, this space is located on the north of the plan, and it's built as a box-in-box construction. And in this photograph, you can see the inner leaf, which is constructed of blockwork. And this is completely encapsulated on the outside with insulation. And the next one is showing the view from the exterior. Here you can see the external wall, insulation and cavity wrapping around. So the construction of the outer wall of the archive was external brick, cavity, insulation, brickwork, and then an additional layer of insulation and then block inside. And that's to completely separate what's inside the archive from the building structure. Now, if we could just jump onto the next image, this is showing a sort of a cross-section of the wall build-up in the doorway, showing the blockwork inner leaf and then the brickwork of the building on the left, and the fire break in between to close off the end of the insulated space. It's quite important to note that the archive was built as a 4-hour fire rating to protect the contents. The next image is showing the construction of the lid of the archive. Now, this was precast planks were sat on top of the blockwork walls, and this acted as permanent formwork for, if you flick on to the next slide, permanent formwork for a transfer slab that was cast across the top. And this was again, insulation between the precast planks and that transfer slab to create a completely separate structure with almost no thermal bridging. And the next one shows, this is a photograph of the interior of the archive, and you can see the interesting thing to note here is the exposed thermal mass in the space, so concrete soffit, blockwork walls, and the floor slab. And this all acts to stabilize the temperature inside. And the floor slab is cast directly on the ground without any insulation, and that's to act as a heat sink to further stabilize it. Here you can see the inside view after plaster was added to the blockwork, and that's important in achieving the tight air tightness criteria for the space to reduce infiltration. And then the ductwork you can see on the top left is a small ventilation system which can run when needed, and a small dehumidification system which we said we needed. Now I'll hand back to Simon, who's our host, to take any questions.
Excellent. Thank you very much, everyone. I think there's one more image there we can leave perhaps on the screen just quickly, just to show you a shot from across the cam of the emerging new skyline to the Magdalene College. Right. Okay. So we've got a number of questions from our attendees today. So we're up to, I think, about 150 attendees. So lots of questions. Do you want to take the image down so that everyone can see, stop sharing the screen, and then we can perhaps everyone see the panelists? Fantastic. So if you want to raise some questions, we've got, as we said, so architects, engineers, we've got a project manager. We've also got our site manager from Cox Edge. I should mention as well, we had Gleeds carrying out the QSing for us on the project. And actually, one of the first questions is on procurement and cost. I think I'm going to hand that one to Oliver from Savills. Oliver, can you tell us a little bit about the procurement route for the project?
Yeah, thanks, Simon, and hello, everyone. The procurement route was I suppose made challenging because the complexity of the building and where it's located, as we've been shown on the slides. So it was important that we got the right procurement route, and a two-stage design and build approach was recommended, really, to enable early engagement of the design team, and along with the contractor to consider all the areas as part of the buildability, and this approach also provided some cost certainty and program certainty prior to going into contract. And I suppose the two-stage approach allowed the design, which was actually taken to stage 4, to be visible, with the design team and the college, so that as it was developed, we had the ability to, if you like, change any of it, and obviously make sure that we were getting the right level of quality that was required.
Super, thank you, Oliver. That's great. So the next question I'm going to ask perhaps to Julian. Sorry, Julian. There's another one on logistics. Someone's mentioned that they thought, how on earth do you get vehicles to site on that project being in the Fellows Garden with no access? Julian, you're on mute at the moment. Yeah.
So we employed a firm who done the tensile system. They used it on the A14 while they was doing the building works there. Our biggest challenge was there was a split leaf beech tree which is at the entrance to the site. Bearing in mind that Chesterton Lane is 4.5 meters higher than our site compound, so we had to do a stepped dig into the site, which Fernando was part of. We used a tensile system for edge protection because using stone gabions would have been too big a footprint and would have encroached upon the trees in the Fellows Garden. So we had to have a minimal impact on the garden, but yet have a road which could take a 40-ton Arctic truck the 4 meters from road to site.
Thank you, Julian. So there was a haul road, basically, for those that might have missed that.
Yes, a haul road. I think we used 1,800 tonnes of fill to build the ramp.
So, Simon, can I just add to that as well in terms of what Julian's mentioned about the haul road? I mean, it was, you know, in terms of being able to control the construction program, we had to get this haul road in place, but it was also driven by the fact that we had to divert the HV cables, which obviously ran through the site. And to allow that to happen, we almost had to accelerate having that haul road in place to allow the HV cables to be diverted by the Stats Authority. So that was, I suppose, an added challenge to try and bring that forward, get it in place, and get them sort of out of the way, as it were, as quickly as possible to then complete the program, the actual construction program.
I guess there was a reason why Magdalene hadn't built on that site for a while before. So yeah, certainly some challenges by the sounds of it. So perhaps a question here, possibly, so this is very topical. Decision to use timber, embodied carbon, and has the embodied carbon for the building structure and envelope being, or can it be shared? So I suppose Neil or Claire or Tim, I'll slightly reword that question for you. When you're looking at these buildings, how do you decide in terms of materials? Does the embodied carbon issue influence your thoughts? I mean, bearing in mind this building was perhaps originally conceived 2 or 3 years ago when the embodied carbon wasn't such an agenda. Perhaps if one of you could take that question. I'm not sure who, you're all on mute, but who's going to have a go at that question?
I'll have a go, Simon.
Thank you, Tim.
Yeah, I mean, as you say, embodied carbon is an emerging issue, and this design was first put together in 2014 when those key decisions about materials were made. But I think from the beginning we were interested in the carbon impact of the project. In fact, the brief from the college was one of produce a building which is sustainable in the broadest sense of the word, and so the use of timber seemed a natural thing to us in many ways. But I think it's true that the thinking about the use of structure was influenced by the carbon footprint of, or the lower carbon footprint of using timber. Obviously, brick, slightly higher embodied carbon impact due to the firing process, but obviously given the context, we felt it was important to be looking to brick primarily as the main means of main material for the vertical construction of the building, and then the timber forms the horizontal construction as we've been describing. And so yeah, I think it was important in that respect.
Yeah, it's interesting, isn't it? I mean, when you look at the building that you're not replacing, but the age of these buildings and how long the building is potentially going to last, I hope to think that it would be many hundreds of years in that position, and that what it's serving. I guess it's a long life design, isn't it? So how much investment you make in terms of spending carbon now is an interesting discussion to be had. Okay, I'm gonna move on to the next question. There was a question, I'm not quite sure about racking, book racks. Why were there so many static book racks? Did we not consider, or sort of fixed book racks, did we not consider moving racks or bookshelves, put it that way? I'm not quite sure who can take that question, but it's probably something for Neil about library design for colleges. Surprise, it says here, I'm surprised by the use of so many fixed bookshelves rather than mobile bookshelves.
I mean, I think if I could take that one, maybe again, the brief in terms of the design of the library has very much come from the college. Yeah. It's been developed with them in a lot of detail with their librarian in order to suit their particular requirements. It's possibly different at a college library to different types of library where there's perhaps more turnover of stock. Mm-hmm. But all of the shelving within the library is flexible in terms of its positioning within each unit. But there isn't any. It's true to say there isn't any mobile shelving within the library. It wasn't something that was asked for by the college.
Yeah, thank you. Probably one for Ben here about oh blimey, how's heating provided? What were the key acoustic challenges? I mean, that's probably a whole presentation in itself. But
certainly.
and very briefly, what were the challenges on heating the building and acoustics?
So heating the building, we've got underfloor heating incorporated into the floor structure. So that's it's kind of involved in the acoustic question as well. So one of the key acoustic issues, I think, in this library, especially with the CLT floor, is footfall noise from the levels above impacting spaces underneath. So what was designed was a floating floor that's sat on rubber mounts with a floor cavity underneath it, and that's actually used for services distribution as well. So instead of a ceiling void, we have a floor void. And then we have underfloor heating beneath the timber floor across the floor plate. And that wasn't quite enough in a few areas, so there's some radiators neatly hidden around behind some fixed furniture as well.
Excellent, thank you. Okay. Somebody asking about could we share the predicted energy consumption for the building? Not sure whether we can do that, but let's just move on. I don't know. Perhaps Ben have a think about that. So the next question was lighting design. Or actually, Ben, I'm sorry, you're on again now. That's
all right. In terms of the lighting design, so the question, I think, where's that question gone?
That was
there it is. Yeah.
Yeah.
So we have quite bespoke light fittings to suit the building. We have a combination of pendant fittings hanging from the apex of the pitched roofs, which come all the way through the voids to illuminate the furniture from an appropriate height. And we have fixed lighting on all the bookshelves. So it's very much focused lighting. And in terms of lighting controls, the question sort of talks about 24-hour access and how that's managed in terms of lighting being left on. So all of the light fittings are connected to a DALI loop with presence detection, and the intention is that they will be zoned so that a user is never left in a sort of isolated lit bubble, but the spaces adjacent to them will also be lit.
Yep.
And but when occupancy is not detected, the lighting would turn off.
Thank you, Ben. All right, we're going to give you a rest now. There's lots of questions, though, for you actually here. So we've got a statement and a question. Brick's story is incredible and exemplifies how beautifully crafted the building is. I wonder if anyone is able to estimate the man hours involved in choosing the brick, trips to York, mock-ups, etc. I have a feeling it may be worth it. Does anybody want to speak a little bit about that story behind the brick and those trips?
Would you like to add something, Claire, and then I'll jump in?
So I guess in terms of trying to add it up, that would be quite a difficult thing to do. I think I guess it started when we started working on the project, and like trips to the college. We went around, I think, at one stage measuring all the joints in the existing buildings, and then as we worked through the various stages, then doing the sample, both the dry laid samples beside the peeps and then the samples with the mortar. But I think it was a very enjoyable process, I think, from our point of view, and it was nice to have so many people involved in that process. So there was a lot of involvement with Smith & Walwork, with Coxsage, with the college, and yeah, from our point of view, I think it was enjoyable and definitely worth it, I think.
Yeah, so from my point of view, I built the test panels. My background's bricklaying, so the ratio of soft sand and sharp, I was trying to make it buildable for the bricklayers. So to add just enough aggregate that when we brushed it, it showed, but not too much that it made it hard to lay the bricks. So I finished up with a 4 soft sand, 2 sharp, 1 lime, 1 white cement ratio, which was passed by everybody, and the colour complemented the bricks. So I've done a lot of heritage work in the past, and I knew that with these bricks, a flush joint would be softer and nicer, especially with some of the bricks having the mottled effect on the front, you know, the indents and the structure to them. So yeah, it was just trying to balance the brick to the mortar and make it usable for the bricklayers.
Thank you, Julian. I'm going to take two more questions very briefly. One that's really easy to answer, and I guess everybody's asking this question, and this is from Feb Phillips. She's saying, how do you stop the heat going up the chimneys? Yeah, how do you do that, Ben?
As with any naturally ventilated building, if you leave the windows open in cold weather, heat will disappear from the building. But no, it's a good question. In terms of the control of those, so at the bottom of each chimney, there is sort of essentially an opening roof window. And the controls of that are quite important so that it opens just the right amount to avoid over-ventilating. And that's something that's yet to be installed on site and yet to be commissioned, but that's something that will need to be looked at in detail when we get there.
Yeah, fantastic. Okay, one more question. Or actually, somebody's asked about why the pile's so deep. I guess, Fernando, that's because it's on quite tricky ground there. There's quite a soft layer of peat, I believe, below the building, isn't there? Well, not peat, but alluvium, sorry. Yeah.
Yes, there was a lot of made ground in the site, and also the fact that we had to raise it a bit. I haven't talked about civils, but we were also involved with the civils, and there was we had to set the building height, the ground floor height, according to the freeboard to make sure the water didn't get into the building when in the event of a flood event, and all those things, and together with the fact that the soils are, we had a very deep layer of made ground and then some alluvium. We had to go for piles, and then ultimately the piles, the length and the diameter was down to specialist design, but we just provided the specific loads from this type of building.
Okay, and then probably a final question.
Just to add to that, the building was actually, the Fellows Garden is actually a flood plain for the River Cam, so that's why Fernando had to lift the building up.
Yeah.
For the 100-year flood or the 1,000-year flood scenario.
Thank you, Julian. So probably the final question was one about extension of the building, and has it been designed to be extended? I mean, I must admit, I don't see how you would extend the building. It's already in the Fellows Garden next to the Pepys Library and next to a quite steep embankment. But perhaps on the brief, either Claire, Tim or Neil, is there anything on the client brief in terms of talking about future proofing and adaptability or extension?
I suspect that the college may be sort of not thinking about extension for a very long time, if at all. I mean, this feels very much like a sort of once in a lifetime project, and the college very much explained it in those terms. So I think they've done everything they can in the briefing, and we've done everything we can in the design to make sure it's well future proofed. But I mean, I suppose that the modular nature of the plan suggests that you could extend it if you wanted to, and it would be possible, I'm sure, to keep going. It's a nice idea, but I think at the moment there aren't any plans to do so.
No. Well, I'm afraid we're sort of running out of time now. We've got quite a few questions. I mean, I don't know if any of the panel have got a burning desire to answer one final question. But while you're thinking of that, I'd just like to say on behalf of the CFCI today, thank you to the whole project team for taking part. It's an absolutely amazing project, fraught with logistics challenges, but also many, architectural heritage challenges, I'm sure, in terms of, we didn't even hear about the planning, but I'm sure that was a challenge in its own right. So that's absolutely fantastic. I have one question for the rest of you now, just before we let you go. In terms of when the library is going to be open for use, I would imagine it's going to be by the end of the year. What's the planned opening date, Julian?
We're unsure at the moment, but we are definitely heading. I spoke to Ollie, and he's around November time, wasn't we, Ollie? Somewhere around there.
Probably a bit mean to ask that. Sorry,
it was. Yeah, it's an unknown at the moment. Footfall on site is our main concern. Footfall on site.
No, sorry, I shouldn't. That was an unreasonable question to ask. I'm sorry, Julian. Okay, on that note, just thank you very much for a really fantastic presentation. Thank you all for actually getting through a huge amount of information in such a short period of time, but and sticking to the idea this was a construction visit, and you've shown us lots of images, so that's really good. Just one final point from me before we all go. We haven't yet advertised our next webinar, but on the 1st of June, we're trying to organise a CFCI webinar on the future of office design, quite topical in the current environment of potentially all going back to work or our offices in the near future. So hopefully keep an eye out on your emails. Hopefully we'll be able to organise a seminar on commercial office interior design 2 weeks on Monday. Okay, thank you very much, everyone. See you all hopefully in 2 weeks.
Thank you.
Goodbye.
Thanks very much, Simon.
Bye.
Thanks, everyone. Cheers.
Thank you. Thank you.
Thank you.
Bye.